So we're going to be balancing some equations using the words, the nomenclature for these compounds, and translating that into a formula and then balancing the formula. So in this question, we have hydrogen gas reacts with oxygen gas to produce liquid water. So what would be the formula for this? Hydrogen gas is always going to be H2 because that's H always comes in pairs and twins when it's a gas. So hydrogen gas is H2 and it reacts with oxygen gas, so plus O2 because oxygen always comes in pairs when it's a gas to produce liquid water, which is H2O liquid. Okay, now the reason why we're saying H2 and O2 is that if you remember, your teacher probably gave you some sort of mnemonic to memorize the elements that come in pairs of two when they're gases. And that mnemonic is have no fear of ice cold beer. So have would be hydrogen, and that would always come in two. N would be nitrogen, and that always comes in two. F would be fluorine, and that always comes in two. Of would be oxygen. I would be iodine. C would be carbon, and B would be boron. So these elements specifically always come in pairs and twos when we're talking about gas. This is how they naturally just appear as gas. They come in pairs. So two hydrogens, two nitrogens, two fluorines, two oxygens, two iodines, two carbons, and two borons. Now, when you're balancing equations, we're going to have some number of moles of H2 plus some number of moles of O2, and that's going to yield a certain amount of moles of H2O. So what we're going to look at is we're going to draw a dividing line down where this arrow is, where the yield arrow is, and we're going to start with the H over here, because that's the H, and there's two of them over here on the left side of this green line. On the left side of this green line there are two H's, so we're going to say 2. And then we have an O for oxygen, and there are two oxygens over here on this left side of the green line. Now on the right side of the green line, we're going to have two H's, which is this right here. But look, we're only going to have one oxygen. So what can we do to get all of these balanced so they're all the same on both sides of the equation, on both sides of the yield line? So we have H2 over here on the left, so check, and we have H2 over here on the right. We have O2 over here on the left, but we only have O1 over here on the right. So we need to bring this up to a 2. So the way that we do that is we add a number here in the molar content and turn this into H2O. Well, that's going to change the numbers because now instead of 2 H's, you're going to take that times 2 and you're going to have 4 H's. So 4 H's. And the 2 also applies to the O. So now we're going to have 2 O's. So now we have hydrogen is 4 and oxygen is 2, but then we have over here on the left, hydrogen is only 2 and oxygen is 2. So we need to change that to 4. And the way that we do that is we put a molar number 2 in front of the hydrogen. So 2 times the 2 is going to equal 4. So now we have 4 hydrogens and 2 oxygens on the left, and we have 4 hydrogens and 2 oxygens on the right. So the total balanced equation would be 2H2 plus O2 yields 2H2O. Okay, so now here's a trickier one. Aqueous aluminum hydroxide reacts with aqueous sulfuric acid to produce aqueous aluminum sulfate and water. So let's start with the aluminum hydroxide first. Now, if you remember anything about memorizing your polyatomic ions, you'll know that hydroxide is always OH and 1 negative. And then there's aluminum. Now, if hydroxide is OH negative, let's look up at the periodic table and find out what kind of ion aluminum is. Let's look up here. So aluminum is going to be right here. So aluminum is in column 3A, so that means it's going to have a positive 3 charge to it if it's turned into an ion. So let's go back to our paper here. So we have aluminum as a positive 3 charge, and hydroxide is only 1 negative charge. So what do we need to do to make aluminum hydroxide? Well, we have our aluminum there, which is a positive 3 charge, and don't we need 3 hydroxides to even out that positive 3 charge with a total of negative 3 charges? So 3 hydroxides is going to mean a negative 3 charge. And so that would go nicely with the aluminum, which is a positive 3 charge. So we would write it like this. We would put parentheses around the hydroxide and put a 3 down here because the 3 only applies to what's in the parentheses. It doesn't apply to the aluminum. It does not apply to the aluminum. It only applies to what's in the parentheses preceding it, the hydroxide. So aluminum hydroxide is Al parentheses OH parentheses closed 3. So that's going to be aluminum hydroxide. Now let's look at sulfuric acid. Sulfuric acid it's going to start with an H because it's sulfuric acid, and most acids start with an H. And then it's going to have this SO to it. Well, the SO stands for sulfate because sulfuric acid is hydrogen and sulfate. Now sulfate is SO4, and you should have that memorized from your polyatomic ions. And SO4 has a 2 negative charge. And hydrogen is only going to have a 1 plus charge. So what needs to happen in order for this 1 plus hydrogen to combine with the sulfate and get a neutral molecule, such as the sulfuric acid? Well, we're going to need 2 hydrogens to combine with the sulfate, which has a 2 negative. So the sulfuric acid is going to be H2SO4. Now we're going to look at aluminum sulfate. Now, how do we write aluminum sulfate? Well, we know we have an Al, that's aluminum, and we know we have an SO4, that's sulfate. And you know SO4 has a 2 negative charge to it, that's sulfate. So aluminum, what happens to aluminum when it's an ion? If you remember going back to the periodic table, this aluminum is going to have a 3 plus charge to it. So let's go back to our page. So this aluminum is going to have a 3 plus charge to it, and this sulfate is going to have a 2 minus charge to it. So what needs to happen for these two to be equal? Well, we're going to need 2 aluminums, 3 plus, and aluminum with a 3 plus, and that's going to give us 6 plus. And then we're going to need 3 sulfates. Here's a 2 minus, and a sulfate with a 2 minus, and a sulfate with a 2 minus. And that's going to give us a 6 minus. So as you can see, the 6 plus and the 6 minus are going to cancel each other out. So that means we're going to write this as Al2, and then we're going to put in parentheses SO4, and then outside the parentheses we'll put 3, because there's 1, 2, 3 sulfates that we need for this. So aluminum sulfate is going to be Al2 parentheses SO4 parentheses closed 3, because the 3 means there's 3 SO4s. Okay, so now we're going to write out this equation, this unbalanced formula. It says aqueous aluminum hydroxide, well that's aluminum hydroxide, and we'll just put aqueous, reacts with aqueous sulfuric acid, so that's H2SO4 aqueous, to produce aqueous aluminum sulfate and water. Oh, and this is aqueous, and water is a liquid. So to write that again, we have AlOH3 aqueous plus H2SO4 aqueous yields Al2SO4 3 aqueous plus H2O liquid. Okay, so what we need to do now to balance this equation is we're going to draw a line down the middle of this yield arrow. So we have to the left of the line and to the right of the line. So first we're going to start with this first element, Al, aluminum. Aluminum. So how many aluminums are on the left side of this green line? So there's AlOH3, and then that's it. So there's just one Al, one aluminum. Now we're going to put down O for oxygen. And how many oxygens are there in this entire left-hand side of the green line? So there's 3 oxygens here, and then there's another 4 oxygens here. So that's going to be 7 oxygens. Then we're going to put down the H for hydrogen, and there's 3 hydrogens here, and then there's 2 hydrogens here, so that's 5. Then we're going to put down the S for sulfur. So how many sulfurs are there? There's just 1 sulfur on this side. Now we're going to do something different real quick before we move on to the other side of the green line. We need to rearrange these so that H and O are your very last things. H and O, I always say save your hose for last. So H and O should be at the very end down here. So H is 5 and O is 7. And we're going to get rid of those up here. So it should go Al, aluminum, and then sulfur, and then hydrogen, and then oxygen. And if you rearrange it so you're always working your hydrogen and oxygen last, it works out a lot better and it's a lot less of a headache. So save your hose for last, is what I always say. So now we're going to go over to the other side of this green line, and we're going to have aluminum. How many aluminums are there? Well, there's 2 aluminums. So 2 aluminums. And then how many sulfurs are there? Well, there's 1 sulfur in the parentheses, but you have to multiply that by the 3 outside of the parentheses, so that's 3 sulfurs. And that's all that is for sulfur. And then save your hose for last, your hydrogen. Your hydrogen has 2 of them right here, so 2 hydrogens, and then your O's. Your O has 4 here, but you got to multiply it by the 3, so that's 12. And then you have another oxygen over here, so that's 13. So you have aluminum 1 on the left side, 2 on the right side, sulfur 1 on the left side, 3 on the right side, hydrogen 5 on the left side, 2 on the right side, and oxygen 7 on the left side, 13 on the right side. So first we're going to do the top one. We're going to do the aluminum. So there's only 1 here, and there's 2 on the right. So what do we need to do? We need to change this aluminum hydroxide to 2 aluminum hydroxides. And let me just go ahead and I'm going to put a number in front of each of these compounds. So it's easier to read. And we still have a green line from that yield arrow. Okay, so we have 2 now, 2 aluminum hydroxides up here, so we can change this to 2 aluminums, but then that's going to mess with the quantity of the hydroxides also, because there's 3 O's and 3 H's in here, but now we have 2 of everything. So the 2 times the 3 O's is going to be 6, plus this O4 over here, and that's going to be 10. So we're going to change this oxygen to 10. And then this hydrogen, there's 3 hydrogens here, but now we've turned it into 2 sets of 3 hydrogens, so that's going to be 6, plus the 2 hydrogens over here, so that's going to be 8. So we're going to change this 10 to 8. And the sulfur doesn't change. So now we have 2 aluminums over here on the left, 2 aluminums on the right. But now see, we have only 1 sulfur on the left and 3 sulfurs on the right. So that means we're going to have to change this, the hydrogen or the sulfuric acid, to 3 so we can get 3 sulfurs out of it. So this 3 hydrogens, this 3 sets of 2 hydrogens makes 6. Then we have to add the 6 hydrogens that we have over here in the aluminum hydroxide. So that makes 6 plus 6 is 12. So now there's 12 hydrogens. And then there's 3 sulfurs. And then we have 3 times 4 oxygens. So that's 12 oxygens plus the 6 oxygens we have over here. 3 times 2. So if we have 6 oxygens over here and 12 oxygens over here, then we have 18 oxygens. So now we have 2 aluminums over on the left, 2 aluminums on the right. We have 3 sulfurs on the left, 3 sulfurs on the right. But now we need to bring this up to, we have 12 hydrogens over here on the left and only 2 on the right. We have 18 oxygens and only 13 on the right. So we need to do something with this H2O. We need to make this a 6H2O because the 6 times the 2 hydrogens is going to turn this hydrogen into 12. Now let's add up the oxygens and see how many we have on the right. So we have 6 oxygens, so that's 6. And then we have 12 oxygens over here from the aluminum sulfate, because we have 4 oxygens times the 3 oxygens outside the parentheses. And so that's 12. So 12 plus the 6 oxygens we have here for 6 H2Os is going to be 18. Now look, we have 12 hydrogens on the left, 12 hydrogens on the right, 18 oxygens on the left, 18 oxygens on the right. And if you wouldn't have rearranged this to save your hose for last, save your hydrogens and oxygens for last, this could have been much more confusing balancing of the equation. But if you move your hydrogens and oxygens and save those for the last, they usually just work themselves out pretty well. Okay, so another one, gaseous butane. Butane reacts with oxygen gas to produce carbon dioxide gas and water. And you see here we gave you butane as C4H10. So we know that butane, gaseous butane, is C4H10. But it reacts with oxygen gas. And do you remember how oxygen gas presents itself? Remember, it's have no fear of ice cold beer. So oxygen is always going to be in pairs, in O2s. So we're going to make that oxygen gas is going to be O2. So gaseous butane reacts with oxygen gas to produce carbon dioxide gas. So carbon dioxide is going to be a C and an O. But how do we know how many C's and how many O's for carbon dioxide? Well, it's in the title, carbon. So that's just one carbon. And then dioxide. That means there's 2 oxygens to go into this. So 2. So it's going to be CO2 because of this prefix di. And the "ide" means it's part of an ionic compound with carbon. So carbon dioxide, the di is going to give you a clue that the oxygen is going to be, there's going to be 2 oxygens. So carbon dioxide gas plus water, and we know water is H2O. Okay, so the first thing we're going to do is we're going to draw a line down the center of where the yield line is. And the first thing we're going to look at are the carbons, the C's. So there are C's, and on the left side of this blue line there are 4 of them. And then on the right side of this blue line there's only 1 C. So 1 C. And actually, let me rewrite this so we have room to draw in our moles. So we have so many moles of butane reacts with oxygen gas, so many moles of oxygen gas, to produce so many moles of carbon dioxide gas and so many moles of water. So we're going to put these blanks in there so we can write the moles, the molecular number in. Okay, so first we do carbon. Carbon over here on the left is 4 of them. Carbon on the right is just 1 of them. And then remember, save your hose for last. So H and O are going to be at the end of this. So let's do H first. You have 10 H's. You have 10 hydrogens over on the left side. And on the right side, you have 2 hydrogens on the right side. And then O's, oxygens, you have 2 oxygens on the left side, and you have 2 over here and 1 over here, so that makes 3 oxygens on the right side. So let's start with balancing the carbon first. We have carbon is a 4 over here, but it's only 1 over here. So we're going to need to make this into 4 so we can change this carbon into 4. So there's 4 carbons. But now that changes the amount of the oxygens. So if there's 2 oxygens here, but there's 4 total CO2s, then that's going to make 8 oxygens. plus this extra oxygen over here in the H2O, so that's going to be 9 oxygens. Okay, now now we have carbon 4, carbon 4. Now back to the hydrogens. The hydrogens are 10 over here on the left, but only 2 over here on the right. So we're going to need to change this H2O into 5 H2Os to give us 10 hydrogens. So that's going to give us 10 hydrogens. But look, that's also going to change the number of oxygens that we have. So we're going to have 5 oxygens over here, plus the 8 oxygens that we have from the 4 CO2. So 8 plus 5 is 13. Now we're going to go back and we're going to check there's 10 hydrogens over here and 10 hydrogens over here. And now we have 2 oxygens and 13 oxygens over here on this side. So the only thing that we can do is turn this into 7 oxygens, which is if there's 7 oxygens, that turns this into 14. So we're still not balanced. So we have 7 oxygen O2s over here. We have 5 H2Os on the right and 4 CO2s on the right. So now we have 14. So now what do? Well, we can go back over here and we can change this 5 to 6 H2Os, which is going to give us 6 times 2 H's is 12 hydrogens. So that's going to be H12. And the 6 times O is going to be 6 oxygens plus the 8 oxygens. And so that's going to give us 14 oxygens. So we're still not balanced, even though we have the oxygens straightened out now. But now we have 12 hydrogens and 10 hydrogens on the left. So in order to get 12 hydrogens on the left, we're really going to have to go up. So the only thing that we can possibly do is turn this butane into 2 butanes, which will give us 8 carbons and 20 hydrogens, which throws all of our numbers off, but that's okay. This is part of balancing the equation. You just have to work it back and forth until it's even. So now we have 8 carbons over here, and let me erase some of this mess. Now we have 8 carbons over here, and we still have 4 carbons over here from the CO2. We have 12 hydrogens, and we have 14 oxygens. So now we have to figure out how to balance these carbons again. Go back up to number 1. We have to figure out how to balance these carbons. If we have 8 carbons on the left, 4 carbons on the right, then we need to change this 4 number into 8. So now we have 8 carbons, but now that's going to change our amount of oxygens now, isn't it? So we're going to have 8 times 2 oxygens, which is 16, plus the 6 oxygens that we have over here. So that's going to be 22. Now we have to go and balance. We have 8 carbons and 8 carbons on the right. Now we need to go back and we need to balance the hydrogens again. So we have 20 over here and 12 over here. So we need to change this into 10 hydrogens because the H2 times 10 equals 20 hydrogens, which changes the amount of oxygens again. So now we have 10 oxygens over on this H2O, plus the 16 that we have on this CO2. So that's going to be 26. So now we have 8 carbons on the left, 8 carbons on the right. 20 hydrogens on the left, 20 hydrogens on the right. 14 oxygens on the left, 26 oxygens on the right. So how do we get 26 oxygens on the left. How do we change this 14 into a 26 oxygen? Well, look, the good news is that oxygen is all by itself. So if we just change this 7 to 13, 13 times the 2 in the O2 equals 26. So that's going to change the oxygen to 26. So your answer is going to be 2 butanes plus 13 oxygens, gas, yields 8 carbon dioxides plus 10 moles of water. And that's your answer.